Alright, here we go. Algebra 1, Chapter 5, 6, graphing two variable inequalities. Alright, so remember when we had y equals 3x minus 4, anything in the form of y equals mx plus b? Well, m was the value in front of x, and b was what we added to that, so in this case negative 4. So the slope here, if I want to graph this, I have b, that value is negative 4, I can graph that, and then the slope, remember, was 3 over 1. Okay, so from here I can count up 3 over 1, put a dot there, and then just follow that slope in either direction. You really just need 2 points and graph a straight line. Now if we change this to an inequality, we say y is greater than or equal to 3x minus 4, well then my solution set doesn't just include this line, but all the values that are greater than this line, so that are above that line. Now when you graph that, okay, you don't have to shade in everything, spend too much time. The way I want you to graph this is just make some perpendicular lines showing graphing away from this, okay? And this will make sense when we do systems, why I'm saying perpendicular lines away. Okay, so I don't want you just graphing like this. Alright? So now if we switch this from being greater than to being less than, it means all the values less than this line. Okay, so it's going to be on this side. Now if you're not sure which side that goes on, you can always check the origin if that's not on the line. See, is the origin part of the solution? Plug in 0, 0. Is 0 less than 3 times 0 minus 4? Well, is 0 less than or equal to negative 4? No. 0 is not less than, so this point is not part of the solution, so the solution is on the other side. Now, if I'm looking at just a less than or greater than and no equals underneath, then that means this line itself, 3x minus 4, this line is not part of the solution, so I'm going to make that a dotted line. And then I can shade in one of the sides. Remember, when we're shading, just perpendicular lines away from your original line that you graphed. Okay, so we want to graph this. So I'm going to put this into slope-intercept form, subtract the 3x from each side, then we get negative y is negative 3x plus 2, and then I'm going to multiply or divide by negative 1. In this case, divide by negative 1 does the same thing, change all the signs, and remember, the sign has to flip. Okay, so then we get y is greater than 3x minus 2. Now we're going to graph y equals 3x minus 2, so y-intercept at negative 2, up 3 over 1. Okay, now we need to decide, is this a dotted line or a solid line? Since this is not equals, that means the values on this line are not included in the solution. Okay, so this is a dotted line, and then we want to know, do we shade above or below? Well, y is greater than, so it's going to be above the line. If you're not certain, plug in the origin, 0, 0. If I put in 0, is 0 greater than 3 times 0 minus 2? 0 is greater than negative 2. That is correct. So the origin is part of the solution. So the solution is on this side of the graph when I shade that in. Alright, now I could pick an ordered pair and say, is this ordered pair a solution for the inequality? Okay, well we could go negative 2 and 3. There's my pair. Plug that in to this equation, say yes, that is true. So you can either determine that this is a solution by graphing it and seeing, okay, it is in the side where the solution is, or you could plug it in here, say this is y, put 3 in there is greater than 3 times negative 2 minus 2, and solve that, get 3 is greater than negative 6 minus 2, so 3 is greater than negative 8, and that is true. So same thing here. If we have another ordered pair, 5 and 0, is that a solution for this inequality? We'll plug it in, 5 and 0. There's my point, and this is not part of the solution. You could also find that by plugging it in here, put in 0 and 5 there, figure out that's not true. If I plug in 0 for y, is that greater than 3 times 5 minus 2? 3 times 5 is 15, minus 2 is 13, and 0 is not greater than 13, so it's not part of the solution. Now in this case, this ordered pair is on the line, 2 and 4. Is that part of the solution? Well, we know that the line itself, when it's dotted, is not part of the solution. So any point on the line is not part of the solution. Again, we could plug that in here, say 4 is greater than 3 times 2 minus 2. We get 4 is greater than 4. Well, that's not true. So that point is not part of the solution. Okay, here's another example. Solve this into slope-intercept form. Subtract x from each side, and then divide by 5. And we get y is less than negative 1/5 x plus 2. To graph that, I'll go to positive 2, put a dot there, and then I go down 1 over 5. Down 1 over 5. Plot this. This is a solid line because it says or equals, so it could be equal to any value on this line, and then it's less than, so my shaded area is going to be underneath, below the line. If you're not sure which side that is, again plug in 0, 0 right here. 0, 0. See, is the origin part of this? This becomes 0, and then is less than or equal to 2. That is true. So the origin is part of the solution, so it is on this side. Is this ordered pair solution for the inequality? We can graph it. We see it is not in the shaded area, so no, it is not part of the solution. What about 0, negative 3? Graph it. Is it in the shaded area? Yes, it is, so it's part of the solution. 5 and 1 is on the line. Now, on the line is a special case, so we need to determine, is it equal to the line? Yes, it is, so if it's on the line, it is part of the solution.
For example 3, notice there is no y, so we're going to solve for x. Subtract 5 on both sides.
That gives us 3x is less than 9. Then divide by 3 on each side, and we have x is less than 3. Now there's only one variable here. Remember, x is something is a vertical line. Okay, so x is less than 3. So all the x values less than 3. So when you're graphing that, that's going to be on this side, everything less than 3. So that side is going to be shaded. Okay, if you're not sure, again, you could plug in 0, see whether that's part of the solution. So put in 0. 0 is less than 3. 0 is less than 3. Check, that is part of the solution. All right, now I can again check for the ordered pair. See, is that a solution? Negative 2, anything in this case with a negative x, right? Negative 2 and 5. Is that part of the solution? Yes, it is. What about 3 and 4? Well, we could go to 3 and negative 4. This is on the line, this point right here. And the line is not part of the solution. So in this case, this is not part of the solution. If I plug this in, my x value is 3. I would put in 3 here for x. 3 is less than 3. That is not true. 5 and 0. Got to 5. And 0, that is part of the solution. And ladies and gentlemen, that's all there is to this. Like and subscribe to the Mastermind channel.